So for part A, it says a saturated solution is prepared by adding excess PbI2 to distilled water to form 1 liter of solution in at 25 degrees Celsius. The concentration of Pb2 plus is the saturated solution is found to be 1.3 times 10 to the negative third molarity. The chemical equation for this dissolution of PbI2 into water is PbI2 turns into Pb plus 2 plus 2I minus. Part 1 asks us to write a chemical equilibrium constant expression. As you can see, it's right here. And we have a 2 over the I, since there would be 2 I minus ions. Part 2 asks us to calculate the molar concentration of I minus in the solution. So since there's 2 I minuses, we would multiply the Pb times 2, so 1.3 times 10 to the negative third molarity times 2, which are the moles, would equal 2.6 times 10 to the negative third. Then for part 3, it asks us to calculate the values of the equilibrium constant KSP. So we just plug the two values in, 1.3 times 10 to the negative third molarity and 2.6 times 10 to the negative third molarity. And we would square 2.6 times 10 to the negative 3. And that'll give us 8.8 times 10 to the negative 9th molarity. So for part B, it asks, a saturated solution is prepared by adding PbI2 to distilled water to form 2 liters of solution at 25 degrees Celsius. It asks, what are the molar concentrations of Pb2 plus and I minus in the solution, and to justify our answer. So I said, since KSP is an independent constant from the volume, and the only change happening is the volume, there would be no difference from part A in the concentrations. So part C says, solid NaI is added to the saturated salt solution of PbI2 at 25 degrees Celsius. Assuming that the volume of the solution does not change, does the molar concentration of Pb2 plus in the solution increase, decrease, or remain the same? And to justify our answer. So I said that the Pb2 plus will decrease. It decreases because the Ni will dissolve, causing there to be more I minus ions, and they will combine with Pb2 plus to create PbI2. And the individual concentrations of Pb2 plus and I minus will be 8.8 times 10 to the negative 9th. So for part D, it says the volume of KSP for the salt BaCrO4 is 1.2 times 10 to the negative 10th. When a 500 milliliter sample of 8.2 times 10 to the negative 6th molarity BaNO3 to 2 is added to 500 milliliters of 8.2 times 10 to the negative 6th molarity Na2CrO4, and it says that no precipitate is formed. Part 1 asks, assuming that the volumes are additive, calculate the molar concentrations of Ba2 plus and CrO2 minus in the 1 liter solution. So for Ba2 plus, it's that we take the volume of Ba and divide by the total volume, and then multiply times its concentration. That'll give us 4.1 times 10 to the negative 6th molarity. And we repeat the same thing for CrO4. And Ba concentration would be half because the volume is doubled. So for part 2, it asks to use the molar concentration of Ba2 plus ions and CrO4 minus ions as determined above to show why a precipitate does not form. You must include a calculation as part of your answer. So we just took the Q, and that would be these two put together, so we'd square it, and that'll give us 1.7 times 10 to the negative 11th. And since Q is less than the KSP, there will be no precipitate.